Presented by the Open Compute Project, or OCP, our podcast increases access to a rapidly growing global community whose mission is to design, use, and enable mainstream delivery of the most efficient designs for scalable computing. On today's episode, I sit down with Daniel Pope, co-founder and CTO of Submer. Submer's focus on the next generation of cooling and automation solutions. We talk about Daniel's background, what Submer is up to today, their involvement in OCP, and the challenges facing the next generation of cooling in data centers today. Hope you enjoy. I'm here with Daniel Pope, co-founder and CTO of Submer.
Hi, Rob. Nice to meet you.
Yeah, you too. Thanks for joining us.
Pleasure.
Well, first, tell us a little bit about yourself.
So my background is in data center design and operations, and that started at a very young age when I decided to switch on a server in my bedroom.
Okay, how old were you when you did that?
16.
Okay.
Yeah. And so that server very quickly grew into thousands of servers over the period of a decade. So I went through the process as obviously getting out of my bedroom.
I would assume so.
And build in a number of data centers that evolved. Everything starting from, I guess, a garage to then like a bigger facility to a bigger one. And then we ended up with a full-size tier 3 facility. And that was quite a journey in Barcelona, which is where I'm based and where I obviously live. Because we experienced, I guess, the .com boom growth, and then the challenges of scaling infrastructure at that speed. I think way before the cloud era, really, because this was like from 1999 to 2009. So I'd say, pre-cloud, most of it. And quite a journey discovering the challenges of scaling infrastructure quickly, like automation, supply chain, and so on. And then in 2009, I was fortunate enough to sell that business to the Telefonica Group, one of the big European telcos that was trying to protect their turf in Europe as hyperscale was moving in.
Okay.
So they acquired a number of large data center companies, and one of them was mine.
Their opportunity to advance quickly in the market, and your opportunity to try something different, do something new.
Exactly. I think we realized that we kind of reached the end of a cycle. It would have meant competing against, obviously back in 2009, the hyperscale customers, partners moving very aggressively into the space.
Okay.
And so it's probably very difficult, like David versus Goliath kind of thing.
Yeah.
So it was like, no, let's forget about this. We've had fun. Let's move on to something else. And so I sold the business back then.
Okay. And your fight then was innovation, and then it was moving towards, facing Goliath. So then Submer comes. What was the antithesis for that? What was the reason?
Yeah. So a few years later, 2015, we kind of took a look at the data center industry, what was happening. And there were a set of very obvious tailwinds. Hard to measure exactly when everything would align, but it was clear that you had this big ESG push, you had this edge push, and also the obvious thermal design power of the chips going up and up. And so it was very clear that at some moment in time, we wouldn't be able to cool like we've been cooling for the last few decades in the data center industry. Pinpointing that moment was impossible in 2015, I guess. But what's become obvious now in the recent couple of years, I guess, is that liquid cooling is definitely the way to go. And so, now we're kind of surfing that wave. But from 2015 till very recently, till 2-3 years ago, it's kind of been a crossing of the desert, kind of waiting for all these other things to align and for customers to be educated, because in 2015, no one really knew what immersion cooling was. And people looked at a tank and they went, this isn't right. What's wrong here? Why is there water in this tank?
Yeah.
Stuff like that. To obviously now, major players using the technology to start and understand the benefits of this technology compared to other liquid cooling approaches, I guess.
Can you identify any key aspects from the customer perspective or the prospect perspective of, okay, now we're going to move to liquid. What's driving it for them? What are they seeing that says we're going to go immersion?
Yeah. So customers are obviously reluctant to move into any type of liquid cooling solution. And the silicon manufacturers have really been fighting against that, meaning they've tried to push as far down the line as possible the SKUs for liquid cooling.
Sure.
And NVIDIA and Intel have been very clear about that. They're like, ideally, we wouldn't need liquid cooling, right? We don't want to create this kind of disruption to the data center industry. But now it's kind of inevitable. We've seen what's happened recently, like with NVIDIA's flagship event in GTC, where all new platforms now are liquid cooled. And we're just going to see more and more in that, more and more of that. Fortunately enough, it doesn't look like the heat flux on the chips is going to increase, but the chips are going to get bigger. The racks are going to get hotter, more powerful. So we're going to see 120 kilowatt racks like the NVIDIA ones, but also bigger than that. So I'd say from a customer perspective, it's mostly been the reluctance to change, which the data center industry is very reluctant to change, right? So,
yeah. There's the famous quote that floats around is the data center industry loves innovation as long as it's 10 years old.
Exactly. And that's exactly why the first stepping stone into liquid cooling is obviously direct-to-the-chip cooling or water-based cooling, because that's been around for more than a decade. It's been used in supercomputers. So it's like the safe next step for the industry, right?
And is that because air then still becomes the media that you're exchanging when you're direct-to-chip, and maybe you're not direct-to-facility water, you're still using facility air? Then now we're not adding pipes, we're not adding bigger changes to the facility?
Yeah, so obviously there's the air-assisted liquid cooling approach that Meta and Microsoft are starting with. I think that's primarily because they still haven't figured out of all these liquid cooling options that are out there, what to bet on, right? Because it's a big bet from an infrastructure perspective. What are you going to build for the next decade or at least, number of years? And so, honestly, I think they haven't made their minds up yet. And so the de-risked option is, let's just put something that I don't need to change my infrastructure yet. I can run those new generation AI chips. I can get them in the data hall. I can get my workloads up and running, but I don't need to touch the infrastructure yet. And that can only get you really. It's just like a short-term patch to the problem. It's obviously great that they can gain the experience and roll out all this generative AI and training models, etc., and so on. That for sure is going to generate an incredible business for everyone. But at some point, they're going to have to figure out how to tackle the infrastructure side of things. And there, I guess that's where we're convinced that the long-term gain is immersion cooling. So when the customer looks at all the benefits that the technology brings from the chip, the server, the rack, the data hall, the water loops, and obviously the secondary cooling infrastructure, so the dry coolers and so on, all that cumulative benefit is an unprecedented TCO compared to other technologies. And we're convinced of that. We're very familiar with it because of what we've done in the crypto mining space, where we've deployed hundreds of megawatts of immersion technology. And those are, I'd say, very TCO-driven customers. They kind of rely on return of investment.
That's the primary function, right?
So they don't know if Bitcoin's going to drop half, it's going to go to hell. So obviously any investment and technology investment that they do is really well measured, but it's driven by TCO. And in the data center industry, we haven't been very good at that because we historically built these siloed teams with facilities teams on one side and IT teams on the other that haven't really had the need to communicate and
Sure.
design facilities together, right? So now liquid cooling kind of destroys that, and it creates the issue of, oh wow, we actually have to design our compute platforms for the cooling infrastructure and the cooling loops that we're going to use, and it creates this whole new paradigm.
Do you think that's changing, or maybe that becomes even more apparent as we move into this AI age where the loads are significantly more? And so where before we would design a data center for 10 kW a rack or lower, the loads were fairly static. There was lots of overhead, so cost of operating it becomes pretty flat, pretty predictable.
Yeah.
Now these new loads are going to be significantly higher. And so does that change how people should look at it?
It's just like another tailwind for this kind of technology, for the immersion technology, apart from the ones that already exist related to like ESG, sustainability, just running the loops with dry cooling instead of having to evaporate water and stuff like that. I think it just adds to the pressure. And if we dig a little bit into what's happening technically, yes, you've got these very high-powered GPUs that are the main problem, but they're not the only problem that's happening now on the board, right? So
Right.
you start to have challenges with, we've seen it here in OCP with liquid-cooled bus bars, which kind of sounds very counterintuitive to
Yeah.
feed water into a bus bar. You start to see liquid-cooled switches. Obviously, the memory TDP also increasing to a point where it becomes a problem on the server. And so there's going to be a point where it just doesn't make sense to put more and more copper to try and take away heat from the compute that you're not going to be able to take away.
Right.
You're turning that server into a kind of radiator, and then you're still increasingly having to deal with the problem of the air cooling portion in the data center, right? So in this generation of compute, maybe you have 20-30% of air that you need to manage out of the racks, but in the next iteration, with the increase of the rest of these TDPs that I was referring to, that 2030 is going to become 40-50. And so it's going to impact the facility PUE, right? And how do you put an end to that? Well, we think it's immersion, basically.
Makes sense. So you talked about a little bit about resistance to adopting immersion. We're at OCP, we're at the regional summit. Where does standardization play a role? Is that the solution for adoption? People become more comfortable with it?
It absolutely is. Yeah, we're convinced of it. We have a big team that's been working in OCP since 2018 when we joined as a member, so already quite a few years. We're actively participated in a number of the different work streams related to power, cooling, and a lot of the standards obviously around immersion. Standards are absolutely key, especially for immersion. I mean, it's a technology that hasn't been around for decades. And so defining standards, getting everyone up to speed with data and reliability, performance, etc., is what's going to get us over the line when it comes to the support and warranty of systems in immersion, which is another one of the barriers of adoption to technology.
Yeah, makes sense. So you've been a member of OCP since 2018. Submer is a platinum member, is our highest tier. So you've made massive investments for just your time as well in OCP. Why give up your lessons learned? Why share it with the public? You could keep it for yourself, and Submer could continue on. But
well, especially for in the case of immersion, where really, I think we're creating a new market, a new technology for cooling, right? And so to do that on your own and trying to convince an industry that is, again, going back to it, so reluctant to change, so reluctant to risk, and naturally it's very natural that it's like that. But having seen what we've seen also like on the crypto side, where if you don't have that legacy, if you don't have that burden, decisions can be made very quickly, and those benefits can come very, very quickly. We think that the quickest way of convincing and educating the data center industry is through solid standard associations. And obviously OCP is one, ASHRAE is another, where we're very active, etc. And we see the benefits, we see the impact. And it's pretty much, it's like a badge of people have confidence in the things that happen in OCP are they make sense, right? And they're valuable. And so we think that it's definitely, it's a big investment, yes, but it's a shortcut compared to not doing that investment and trying to push direct, trying to convince these
fantastic
customers and the collaboration also between, because it's not just obviously the end goal of let's get this technology into the hyperscalers' hands. It's all the technology vendors that can actually benefit from better cooling as well, because it's not just the data. For example, Micron creating memories for compute platforms. Their feedback is, hey, like the limitation on AI is going to be the fact that we can't cool the memories directly. And better cooling of the memories is going to unlock better performance of AI platforms.
Right.
So those are challenges and that can be easily tackled in the OCP environment, where you have this collaboration across different partners and members and so on.
And is it also like, I think we'd have that still in an air-cooled environment of, and OCP has the history of different vendors and different pieces of technology working with each other, but is it more tightly coupled because we're in liquid now? Now you have a facility. Okay.
No doubt. I mean, with cold plate, it starts to get more tightly coupled because you are bringing cooling right onto certain components, right? And so you can't have a thermal design without considering what the heat sink or the cold plate is going to be like, etc. In immersion, it goes an extra step, right? Because it's direct.
Every component.
So then it's like every component, material compatibility, obviously reliability and durability of these fluids, performance, you name it, right? And then we've been focusing on all these different areas in all the different work streams to prove that there's a solid technological runway, that these fluids are safe, and they can be even safer if we invest in the right R&D and direction for greener, more sustainable fluids.
Yeah. So now it's not only just the components. Now it's you have a fluid piece of it itself. I saw a recent publication you had, and it was a diagram of a Submer tank for ORV3.
Mm-hmm.
So you have a new contribution on the OCP database.
Yep.
It's your ORV, your tank ready for ORV3, and it has pictures of all the partners that are involved in sharing them, also sharing like, yes, our products are compatible, with your solution. Tell me a little bit about that.
Yeah. So we there's already a network of partners, I think around 15, that have products that are validated for immersion. Everything from power shelves to components to servers to cables to the fluids, you name it.
Right.
And obviously each one of those, and it goes back to what I was referring to before, like if you look from the chip and all the components all the way out to the exterior infrastructure, there's benefits at every level. So for example, power shelves. We can run 3 kilowatt, with very few modifications, a 3 kilowatt power supply can run at 7 or 8 kilowatts. And it's just because the fluid is non-conductive. It's managing much better the thermal management of the heat around the power supplies, etc., and so on. The bus bars, they're submerged in the bottom of the tank where the coldest fluid is. So forget about having to run water through them.
Right.
And we've some of our team will be talking about the performance of those bus bars compared to air and compared to other environments. So For example, now the conversation is, oh, we need to design an open rack V3 for a 100 kilowatt rack. All of a sudden, those bus bars in there need to be humongous. So there are tons of copper there now. Well, if you use immersion, you don't need to do that. You can use the same bus bars up to 300 kilowatts, which is what we'll be talking about during this week, with the same amount of copper, just because they're very well cooled in immersion, basically. So again, every single component, we believe it's inevitable that it's just a matter of time and education and standards and getting people to feel comfortable. But all these little things add together to a point where, again, unprecedented TCO.
Yeah, so you get improved performance, reduction in material usage, right? Because now these copper bus bars aren't
much less copper, obviously no cold plates, etc. Failure rates compared to air, in air being around 18%. Most of the server ODMs tell us. In immersion, less than 1%.
Yeah, along with fans, no moving parts. That's simple. That's an obvious thing.
Thermal stability, no vibrations, etc. Just things that are obvious. There's still not a lot of data, and so that's what we're mostly working on with the community. But one of the things that people typically challenge is immersion operations. Oh, that's got to be a nightmare.
Sure.
Why would you want to do that, and so on. And honestly, if you have less than 1% failure rate, you might not even have to plan for immersion operations. You might as well just account for an extra 1% of the servers in that tank and say, hey, when it reaches its end of life, I'm not going to touch it. Like if a server fails, screw it.
I think a lot of hyperscalers are used to that approach somewhat anyways. In that situation, it sounds like you're just skipping the problem altogether then.
I mean, we're working obviously on all the standard operating procedures.
So you're still going to need them.
And the operations cranes and carts, so that immersion operations can be done as easily as possible and as quickly as possible. And it's very easy for us to convince customers that if the ones that have experience with operations in direct to the chip very quickly get it, that in immersion, it's not harder. It's probably similar in regards to the challenge. But the massive reduction in hardware failure rates is what really makes a difference, I guess.
Yeah, that makes sense. I hadn't heard that before. It seems very obvious, that everybody's talking about we have to cool these chips. But what you just kind of shared with us, it's way more than the chips. Is that what everybody's missing from the story, or is there something else that people aren't talking about that should be?
Yeah, so the chips are important, absolutely yes, but we've reached the point in the chips where the thermal resistance, so how much heat is produced per millimeter square, has kind of reached the tipping point. And now it's not about more powerful chips. The fact is they're not going to be more powerful per millimeter square. They're actually going to be bigger. They're going to produce more heat because the chips are going to be bigger. But if you can cool them today with whatever approach, we've shown, like in OCP Regional Summit, we showed approach called force convection heat sink, which is a way of accelerating the fluid through the heat sink to deal with thermal resistances that would be equivalent or competitive to direct to the chip type of thermal resistances. If you can overcome that, now it's going to be more about actually how many kilowatts can you extract from one of these tanks, and how can you do it in a way that you don't need additional infrastructure in the data hall, right? And going back to the percentage of air cooling that's required with other technologies. So if you can avoid that and bring it down to an absolute minimum, like we can in immersion, which is like 1% is the requirement of air cooling in a data hall, then it's very easy to design a data center with full dry cooling all year round. And so that's unprecedented. No one is able to do that today. And there is no other technology that will be able to deliver that. And we've done that at scale in crypto, hundreds of megawatts in the middle of the desert, running completely dry with overclocked compute systems. Compute as in obviously crypto mining equipment, but there's still FPGAs. So So we know that it's technically feasible. We know that it delivers the most compelling TCO, and it's just a matter of educating the data center industry and putting them on that same journey, right? So we're convinced we'll get there. That's the strategy. And OCP, without a doubt, is the best place to have those conversations.
Oh, that's good. Great to hear that. So everybody, it does still feel like many people are playing catch up. We came out of COVID, and we have this AI wave. What is the next? Any predictions on the next 12 to 18 months?
I would say that there's been some conversations around this in the keynote, right? But now we're like in this moment of invention and investment in AI, right? But at some point, and I think that's going to happen in the next 12 to 18 months, someone needs to sign off on the infrastructure design that is going to be implemented to deploy all this AI infrastructure at scale.
Behind the data centers? So you're talking about things like utility power?
I'm talking
communication?
So I'm talking about utility power, but primarily I'm referring to a kind of, I'd say, blueprint for AI factories, as NVIDIA calls it, right?
Mm-hmm.
So what is the blueprint to build an AI factory? What is the most sustainable, efficient way, and from a performance perspective, to build these next generation AI factories? We believe we've got a very solid story for that. As I mentioned, I think most of the hyperscalers still haven't wrapped their heads around that, and that's why you see air-assisted liquid cooling being kind of the first way to say, hey, I've got liquid in my data center, but you really don't.
Right.
So I think in the next 12 to 18 months, what we're going to see is those blueprints being pinned down for the next generation, or the first generation of truly AI, of true AI factories.
Yeah, AI designed, specific design facilities.
Facilities that are resilient to at least 2, 3, 4 hardware refreshes, right? Because what isn't resilient to that is obviously the initial approach that's been taken with air-assisted liquid cooling. And what isn't going to be able to support that either is the fact that you have this big leap from with direct to the chip, with the percentage of air cooling requirement for the data hall increasing with each hardware refresh. That's something that's impossible to sustain. So the fact that you now move from 400G and then 400G networks to 800G networks, creating a big problem from a temperature perspective on switching and network cards, etc., and so on. That you have this memory from DDR5, DDR6, etc. All this adding into the direct to the chip designs expiring very quickly.
Okay.
So I see it as, how can customers, and especially hyperscalers, come up with a design that is going to be resilient to 2, 3, 4, 5 generations of compute? And at the speed that things have accelerated the last 2 or 3 years, it's very difficult.
Yeah.
It's a very difficult challenge to solve, but there are definitely options out there, I guess.
Yeah, it sounds like you're, I hate to use the word future-proofed, but well more equipped for the future, because it sounds like those things that people aren't thinking about, memory that you mentioned, networking now too, that are outside the chip, over this hyper-focus around the chip itself, because that's the biggest change. There's a long tail of other evolution of technology within the data center around that chip.
Yeah.
That people aren't prepared for.
And that's what's happened. That's referring to what happens in the data hall, right? But outside, so yeah, let's say more from a pure infrastructure perspective, then it's about, we call it climate resilient data centers. And climate resilient meaning, you can look at it from 2 ways. One would be, well, I want to make sure that I can use dry cooling infrastructure anywhere in the world, that I don't consume water to run my infrastructure, which is going to be a bigger problem in the future. Already a lot of the large hyperscale customers are very challenged by water shortage and projects being halted because of that and so on. The other aspect is when we talk about climate resilient data centers is the fact that we are really going, the good thing of AI is that we can start decentralizing again a lot of these workloads, especially now in the training phase. And so heat reuse is something really good that we could do with these facilities if they're decentralized and they're in regions where heat reuse can be used. So again, back to the technology, but on the impact side of things, on the ESG side of things, having a single blueprint that can solve everything that happens in the data hall and then everything that happens on the infrastructure side so that you have this climate resilient capability of one blueprint serves all. Right. This is kind of, I think, what we'll see in the next 12 to 18 months, hopefully.
And another opportunity for standardization and innovation. Yeah. Fantastic. So, first, thank you so much for sitting with me and sharing. Sharing about Submer, your background in the start, your experience from the owner-operator side, and then we got into the technology itself and the changes. Anything you want to leave us with?
No, just thank you very much for having us here. And obviously, if anyone would like to understand and a little bit more in detail all these things that I've been referring to, please feel free to reach out. And yeah, thank you.
Yeah, of course. And your website's fantastic. It's very clear. So I'll implore people to go visit it.
Thank you, Rob.
All right. Thank you.